Welcome to Insight Builder channel, large language model automators, agent enthusiasts, and my dear friends. Can you tell me about LLM agents? How prompts along with programming logic solve the tasks? In the past couple of videos, we have been discussing how we can build a simple agent, and we saw a demo of a simple agent. Following that, we introduced the Jinja templating engine. We have seen through those videos that we have to create the prompts, and these prompts are actually feeding the large language models, and that prompts actually make the large language models to act like agents and to decide and do stuff that we want. We have to find a way how we can actually leverage those prompts that is created by the Jinja template and use programming logic to solve the tasks. Okay, what we are going to do is, in this video we are going to try and create a code generation task, and we are going to solve it. So in order to do that, we need to do a couple of things. We have to have a way to interact with the internet through some way, some form, that we will see how we are going to do that. And then we are going to collect the information and then feed it to the code generation prompt and code generating agent, in fact, and you will see that it's just a prompt. And then we are going to create a file out of the output. So this is whatever we are doing is part of the simple agent that we are building. And in the next discussion or in the video, I will explain to you how that simple agent works with the programming logic underlying that. With that introduction, let me go to the task functions.ipynb. This is a notebook that is already present in the let it load. It is present in the GitHub repo. The repo link will be shared to you guys in the description below. I hope that it has loaded. Yeah, it has got loaded, and I believe that most of the stuff are still intact. So what I have done here is that I have imported Jinja related classes and functions, and I have created an environment where I am looking at the folder Jinja_prompt. So if you guys are new to Jinja, I would like to suggest the earlier video that I have introduced this templating engine. And these are all supporting functions for Jinja environment. And here I am importing OpenAI related and JSON related supporting classes and functions. Here I have listed the various models that we can use, but I'll be primarily using the economy model, that is model used Echo, that is GPT 3.5 Turbo. And this is the system prompt that I'm going to use. So you can see that I am going to use a system prompt that says that the LLM is a programming expert. So you are an expert in coding a given task using the information provided to you. So that's the system prompt. And here comes the actual agent. Yeah, this is one of the important ideas that I want to share with you guys. Agents are nothing but the large language model API endpoints or the large language model themselves. So agents are not anything special. They are just text generating large language models or AI models. But the way you feed them the system message and the user message is what makes them to act like an agent. And these user messages and system messages are actually prompts, and these prompts contain a lot of decision making mechanisms. And how to create those decision making mechanisms is done through the Jinja templating formats. So let's proceed. So here, whatever you are seeing here is basically OpenAI client has been instantiated with the API key. Following that, the model has been called, and then the respective temperatures have been set. And one more important point is that I have also collected the tokens that is used for this particular call. So in that way, what will happen is I can see how many tokens are getting used. That's one of the important tasks for most of the people. The tokens are part of the response. So take a look at that, you will understand it. Take a look at the API references in OpenAI, you will get this information. And finally, I am getting the assistant message as a response. So this is what this particular function does. Now that is the basic starting point, but the most important point is the code extraction prompt that we are going to use. And the second important point is the Tavily client that we are going to use for searching the internet. So the question that we are going to work on is split a text file with the list of tasks that are separated with /n. That is, I have actually escaped the /n new line character using Python code. So this is the question that I'm going to ask the agent. So in this case, as I already told you, this is the agent, right? The LLM call to OpenAI is the agent. And then I am going to use Python logic to save the data that is coming out. So you'll be seeing how it works. Let's proceed. So here I'm using Tavily search and I'm going to search for this question. And once I search for this question, this is the output you are going to get. So it gives you lots of information from pythonbeginners.com. It also goes to realpython.com. It goes to other Stack Overflow. It starts getting information from various locations. And what I'm going to do is I'm going to take all this information and I'm going to place it inside this search out list. So if you go here and if you look at the search out, and if you look at the element 1, you will see that it is part. Okay, just a second, sorry about that. You can see that here is a list of file contents and it actually provides the search results. So there are lots of search results that has been received from the Tavily client, and we are collecting all those search results, especially the content only, into this search out list. And once that list is received, what we are next doing is we are actually using the code extraction prompt template. So this is the template that we are using. I'm going to cut it and paste it in a new cell just so that you guys can see what's happening. I want to render this template and show you that how it looks. So I'm going to use coder temp and I'm going to render it, and when I'm rendering, I'm not going to give any kind of input. So as you can see here, the just a second, let me zoom in. So here the coder template basically has a prompt which says that you are an expert coder and researcher, you are approached by so and so project manager with a question. So the question will be here, and you have searched for the question and found the below information using the code. Using that, write the code, but here the information will be filled up. So you will be seeing that in action in the next couple of cells. So let me clear this cell, and what I'm doing here is that I am going to run this particular I'm going to create the context where I am going to say net data is equal to search out and question equal to question. So the question that we are discussing here at the top. So this is what we are going to feed to the coder. Sorry about the up and down movement. That's what we are going to move to the coder temp render context. So once we do that, it will actually render, and now the same context that you saw, you will see magically gets shifted right now. It gets modified. You can see you are an expert coder, the same line is there, but here is the question that we asked along with the new line character, and you have searched about the question and found the below information. Using that, write the code, and below this there are lots of information that has got filled up. This context has come from the search results, and that search results has been updated here. So it has been done through the Jinja templating process. That's how you have got it here. And finally, I am telling in the prompt that write the code by mentioning the programming languages first, and that's what it's going to do. But before we jump into the next step, you have to understand one thing, that this particular prompt that has been rendered is going to be the user prompt. We are going to use the system prompt as programming expert. So these two things are required. Even though the user prompt is having a lot of information, but the system prompt should still tell to the large language model in OpenAI case that it is an expert programming model. So that's important. After that, we are going to use LLM call OpenAI. So as I told, this is the agent in this case, and I am going to make this call. Once I make this call, let me complete the call. And once I do that, it will actually print me the number of tokens used. So it's saying that almost 806 tokens has been used and the call has been successful. If the call was failed, then I would have got an error output here. Next, I am going to take the response into this responses, and I am going to snip out the first 9 characters in the responses and the last 3 characters. let me tell you why. Let me actually print responses. See, as I told, in case of the output, there will be Python in the beginning, and at the end there will be three quotes. So you can see that this is the code that is written by the agent. So this is the agent I told you, and the code has been written. After the code has been written, I can snip this out using this code logic, and I will get the output like this, where the Python is missing right now. You can see that snippet is also missing, and I can write the output to python code.py. This is the code file that you will get at the end. So if I open this Explorer in the side, and if I open the python code.py, you'll see that the entire code has been written to the file, and you see that it was not done entirely by the large language model. Yes, the part where we are sending the prompt is where the large language model is involved. Apart from that, rest of the things, the preparation of the prompt, connecting to the internet and trying to get the search results and populating the search result into a list, and even searching and understanding, getting the question, everything is done through the coding language logic. So without the coding language logic, you will not be able to feed the large language model or the agents with the necessary inputs. Whether it is from the internet, whether it is from your vector stores, you still need the programming logic. But what benefit the large language model does is, based on the text data that you have filled. So for an example, if I scroll down a little bit slowly, you'll see that it is going to take text like this, and it is going to understand it, and it is going to give you the output that is very useful. So this is the input. So this is the text that we are feeding in. It's a lot of text, but it reads all those things, and it gives an output that is very concise. Yeah, I have asked something which is very simple, and if you're going to work with a complex task, so this might be a single task that it is going to do. It's not going to be, it's not going to be one code that is going to be written. So if you're going to do the same thing, and if you're going to modify the question, so for an example, there are some 8 tasks that involves code generation. So what will happen? You will, if you go up, you will actually wrap all these things that I've done here into a function, and then you will send the question, or 8 questions that have to be solved through coding, into that function, and that function will create the code, parse the code that has been given by the large language model, and then it will provide you 8 files. This is what you see when you are working with various agents in the real world. So in the real world, let me zoom out a bit. So we have already seen a lot of coding agents in the wild, and most of you must have been already puzzled. So there are lots of agents like Devika, GPT-Pilot, Devin, AutoDev. There are new agents also coming into the market time and again. But all these agents at the back end, they are going to have programming logic that's going to feed them the input and the task that you are asking for, and then it is going to give you the code. So what is the important point I want you to understand from this? The important point to understand from this is that you still need to understand programming logic. So yeah, you have to still write software. There are going to be software engineers. The difference is that the engineers are going to work at a different pace and different level of abstraction right now. The reason why I'm diving into all this base level of understanding of how the agents work. The base level means the level where you are calling the agent, the large language model in this case, and you know that after some days, maybe in another 6 or even a year, we may not even touch this particular request and response call, or the completion.create method. We may not. In the last, from LLM ChatGPT introduction till date, there has been a couple of modifications in this class and method calling, but still after 1 year it is still there. but in the next 1 year, we don't know how much it is going to change, because as more and more agent related programs are getting coded and getting developed, the importance of the underlying large language model gets slowly pushed into the abstraction level. So most of them even may not realize that there is a simple large language model sitting at the base doing the work, but on top of it there are lots of logic, like as you see here in this case of Tavily client, in case of this for loop that we are running, and most importantly in case of this kind of a get template, Jinja templates that we are executing. In fact, Jinja template is one of the confusing aspect for many who come into the programming world, because it takes a level of imagination to think, okay, there is going to be a template. Let me go back. There is going to be a template which is going to be filled programmatically with information. So it takes a lot of imagination, right? So the Jinja template actually takes a template like this and fills the variable one by one into the template. So it's not straightforward. So that is the primary reason why I have been diving into this level of detail and sharing you what's actually happening in the agent. Now this is just a part of the agent. Let's go back to the agent area, agent flowchart, and you see that this is part of the agent. Code generation is part of the agent, code execution is there, browser interaction is there, keyword extraction is there, and after that there is actually getting the objective, planning the steps, splitting the steps, aggregating and segregating the tasks, and then getting the response. All these things will involve lots of Python. So you see there is Python loops, there is Python helps here in some way, there is going to be Python API involved, and finally there is going to be Python print that prints the output. And in order to call the OpenAI, we still have Python API or some kind of an SDK. I'm telling Python in these cases, but it can be any language. It can be Go, it can be JavaScript, or any of the languages that help. However, the most important point, as I again repeat, is that the major heavy lifting of writing code will be slowly and steadily moved into the abstraction, and large language model will take over. Our role as software engineers, developers, and future leaders will be to understand how to leverage this power that we have got from the large language models. And with that deep introduction, I believe that you have got some very strong understanding on how agents are powered using large language models, and how we can make them to work for us using the programming logic that we already know. With that said, I believe that you have learned a thing or two from this discussion, so do leave a like and subscribe to my channel. And most importantly, there are 4 words that I always say: practice, 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 practice. See you guys. Have a great time.